When you're working in a part and you're working with the tolerances, you know that we can go to manage, and we can go to manage here, our tools, and we can set up our application options. And our applications options are going to kind of tell us how Inventor wants to work. If you go to part, you can set it up to, on new part creation, sketch on the XY plane to start with. And whenever you go into sketching, you can actually set up for horizontal and vertical to be implied instead of parallel and perpendicular and those kinds of things. But when I'm going to close this and I'm going to go to documentation or document settings. Even though this isn't a document, this is actually controlling the lighting, the material. You can change the material here. If you go into units, you can change it from inches to millimeters, and it will change. It will convert all the inches to millimeters. So that's one way to convert it if you didn't start out in a metric format. When you go to modeling right here, let me see, default tolerance. So when we go and we look at our drawing tolerance block, what does our drawing tolerance block say? So if I say use standard tolerancing values and I click here to add, I could say 3 place dimensions per the title block on the drawing will be 5 thousandths. 2 place dimensions will be 10 thousandths or 15 thousandths, I think it said. And if I go to single place, this should have been 2, right? And then this one, being a single place, would be 30 thousandths. And I think that's what it is in our title block. In our precision on our angles, by a whole integer, we're going to have a tolerance of plus or minus a half a degree, and apply. And that applies to the entire part. So now if I go into the extrusion and I edit the sketch, notice that every one of my dimensions has a tolerance on there now. Now I can choose for the tolerance to show in the drawing or not to show. But right now the neat thing is that I can set the precision on my tolerance, on my dimensions in my part. So let's say that we don't really care how tall this goes because there's nothing that goes on top of this head. So I could change this in dimension properties. I can change that to a 2 place precision. And right here's our default precision. And I'll apply that. And you can see that that default precision is plus or minus 15 thousandths. So if I said that the worst case would be that it's too tall, then I would say the evaluated size wants to be the upper. And you can put a name on the setting for the dimension right here. When I apply that, say OK, notice that a line goes underneath this. That means that I've applied a worst case scenario to it, and I want it to factor that in while it's being modeled. So when I finish the sketch, the part actually goes to that upper level of modeling. So it actually stretches. So if I say I want a distance from here to the bottom, it's 2.765. So it's actually taken in that 15 thousandths and it's added it because I said that was going to be my worst case, is it's too tall. If the worst case is that it's too small, you have to look at that. If you have a pin in a hole, the worst case for the pin is going to be the largest. The worst case for the hole is going to be the smallest. So you're looking at your fits between your parts. This one really doesn't make any difference whether it's too tall. Maybe it's the worst case is that it's too short. So let's edit the sketch again. And some of the things that I might look at here, alright, maybe this can be 2 places. So I can go into dimension properties and make this 2 places. And right here is one. So if there's another part that's supposed to slip inside here, the worst case scenario is that this would get too short and that it would interfere, right? So if I go in here and I'm going to go to dimension properties, I change this to a 2 place dimension, and I say that my worst case is that it's too small. Worst case is that it's the smallest dimension from the bottom. That would make that notch the shortest, and it might interfere with the part that goes in there. Does that make sense to you guys? Now the other ones over here is the median. When you have a plus a limits tolerance. When you have a limits tolerance and it has the upper limit, let's say it's 175, and the lower limit is 165, and you go to the median, it's going to be 170. That's what it's going to model it to, right? And this one right here is nominal. So do you want to just keep it nominal in the model? So this is something that's pretty new for 3D modeling, because there hasn't been any kind of software that's actually taken tolerance analysis into account. There's nothing that I know of that actually takes GD&T and actually makes it to its worst case that I've found. All right. So if you change the tolerance types, default tolerance would be what we just set up in the document settings. Symmetric tolerance, I could come in here and I could say that this symmetric tolerance is plus or minus 0.020 and say OK, and it'll override that default tolerance. If I go back into the dimension properties, you also have something that's called a deviation. So this is when you can have plus 5 minus 0. And what is a plus 5 minus 0 kind of tolerance called? Unilateral. It only goes one way. So a lot of times it's really easy to put a unilateral tolerance on a pin in a hole. You say the pin is 1 inch minus 5 thousandths plus 0, and it's not going to ever be bigger than 1 inch, right? Because it can't get any bigger. And then with the hole, you would say that's 1.005 minus 0 plus 5. Then that's always going to fit with 5 thousandths tolerance to the worst case scenario. Does that make sense? Okay. All right, so there's deviation. Limits stacked, so the upper and lower limits. Limits linear is just going to put them in a different format. Maximum and minimum. We're going to talk about when we use maximum and minimum in the Krulakowski book. So it's kind of interesting when you say a minimum of a radius of 0.25, the maximum would be when it impedes other features. So if you're just saying a minimum, you're really leaving it wide open. It just can't impede other features on the part. All right. All right, so in the document settings, if you want to use the standard tolerancing, you would check this box and then you could put these in, and then that would be good for that part. So what we might do is, since we have, I'm going to look at his drawings and see if he has a general tolerance on these drawings, because if he does, then if he's using his general tolerances, his parts all fit together, we'll use his same tolerances. And we'll change our formats to fit that. Unless we want to go through every one of them. We will analyze all these tolerances, because the last time we had a machine drawing like this, there were a lot